What you are about to see is straight from the May 2026 Supplementary Mathematics exam, written just last week. That means this is not some old textbook question. This is real, fresh exam content that students across the country just wrote. And if you are watching this, chances are you either wrote it and want to check your answers, or you are studying and want to know exactly what the examiners are testing right now in 2026. We are tackling question 8, a cubic function problem worth 13 marks. It tests everything: factorizing, derivatives, points of inflection, and tangent lines, all in one question. So whether you got it right or you got stuck, stay with me. We are going to break every single part down so clearly that by the end, you will wonder why it ever seemed difficult. Let us get into it. We are given the function h of x equals negative x cubed plus px squared plus qx plus r. Now, the graph of this function is drawn, and we are told three important things. First, the x-intercepts are at c, which is the point 2, 0, and d, which is the point 5, 0. Second, b is the y-intercept. That is where the graph crosses the y-axis. Third, a and c are the turning points of the graph. Turning points are where the graph changes direction, from going up to going down, or the other way around. Our job is to find the values of p, q, and r, then answer a few more questions about the graph. Here is the key insight. We know two of the x-intercepts, x equals 2 and x equals 5. But wait, look at the graph carefully. The graph touches x equals 2, but does not cross it. That means x equals 2 is a repeated root. In other words, the factor x minus 2 appears twice. So we can write h of x as h of x equals negative times open bracket x minus 2 close bracket squared times open bracket x minus 5 close bracket. The negative sign is there because the graph is a negative cubic. It starts high on the left and goes down to the right. Now let us expand this step by step. Step 1. Square the bracket x minus 2. X minus 2 all squared equals x squared minus 4x plus 4. Step 2. Multiply that by x minus 5. Open bracket x squared minus 4x plus 4 close bracket times open bracket x minus 5 close bracket. Expanding gives us x cubed minus 4x squared plus 4x minus 5x squared plus 20x minus 20. Now collect like terms. X cubed minus 9x squared plus 24x minus 20. Step 3. Multiply everything by negative 1 because of the negative sign outside. H of x equals negative x cubed plus 9x squared minus 24x plus 20. Now compare this to the original form. Negative x cubed plus px squared plus qx plus r. Matching the coefficients. P equals 9. Q equals negative 24. R equals 20. And that is exactly what we were asked to show. This one is short and sweet. B is the y-intercept. That means it is where x equals 0. We already know r equals 20, and in any polynomial, the constant term is the y-intercept. So h of 0 equals 20. That means b is at the point 0, 20. O is the origin, which is 0, 0. Therefore, the length of OB equals 20 minus 0, which is simply 20 units. The point of inflection is where the graph changes its curvature. Think of it like this. The graph goes from bending one way to bending the other way. It is the balancing point in between the two turning points. To find it, we need the second derivative of h of x. We have h of x equals negative x cubed plus 9x squared minus 24x plus 20. First derivative, h prime of x equals negative 3x squared plus 18x minus 24. Second derivative, h double prime of x equals negative 6x plus 18. Now, set the second derivative equal to 0, because that is where the inflection point occurs. Negative 6x plus 18 equals 0. Negative 6x equals negative 18. Divide both sides by negative 6. X equals 3. Now, substitute x equals 3 back into the original function to find the y-coordinate. H of 3 equals negative open bracket 3 close bracket cubed plus 9 times open bracket 3 close bracket squared minus 24 times 3 plus 20 equals negative 27 plus 81 minus 72 plus 20 equals 2. Therefore, the point of inflection is at the point 3, 2. This is the most challenging part, but we will break it down carefully. We are told the tangent line has an angle of inclination of 96.34 degrees, and it touches the graph between B and C. Step 1. Find the gradient. The gradient, m, equals the tangent of the angle of inclination. So m equals tan of 96.34 degrees. If you type this into your calculator, you get m equals negative 9. That negative value makes sense. An angle greater than 90 degrees means the line slopes downward from left to right. Step 2. Find the x value where this gradient occurs. We set h prime of x equal to negative 9. H prime of x equals negative 3x squared plus 18x minus 24. So, negative 3x squared plus 18x minus 24 equals negative 9. Add 9 to both sides. Negative 3x squared plus 18x minus 15 equals 0. Divide everything by negative 3. X squared minus 6x plus 5 equals 0. Now factorize. Open bracket x minus 1, close bracket, times open bracket x minus 5, close bracket, equals 0. So x equals 1 or x equals 5. Step 3. Choose the correct x value. The question says the tangent touches h between B and C. B is on the y-axis and C is at x equals 2. So the x value must be between 0 and 2. That means x equals 1 is our answer. We reject x equals 5. Step 4. Find the y-coordinate at x equals 1. H of 1 equals negative open bracket 1 close bracket cubed plus 9 times open bracket 1 close bracket squared minus 24 times 1 plus 20 equals negative 1 plus 9 minus 24 plus 20 equals 4. So the point of tangency is 1, 4. Step 5. Find the equation of the tangent line. We use y equals mx plus c, with m equals negative 9 and the point 1, 4. 4 equals negative 9 times 1 plus c. 4 equals negative 9 plus c. c equals 13. Therefore, the equation of the tangent is y equals negative 9x plus 13. And that is question 8 from the May 2026 supplementary exam, fully broken down step by step. If you wrote this paper last week, I hope this gave you clarity on where you went right, or where those marks slipped away. Every mark in this question had a clear method behind it, and now you have seen exactly what that method looks like. To summarize what the examiners were testing. For 8.1, they wanted to see if you could read the graph and build the factored form using repeated roots. For 8.2, a 1-mark gift if you knew that r is always the y-intercept. For 8.3, second derivative set to 0. That is all they wanted. For 8.4, the angle of inclination was the trap. Most students see 96.34 degrees and freeze. But once you know that gradient equals tan of theta, the rest is just algebra. These are the exact skills that come up time and time again in cubic function questions. So if this was your supplementary paper, use this video as a lesson going forward. And if you are preparing for your own exams, you have just seen the standard you need to meet. Like this video if it helped you. Share it with a classmate who needs it. And subscribe, because we're going through more papers just like this one. See you in the next one.